This is Dominic Schweier. Welcome to my presentation on defensive programming. Wikipedia defines defensive programming as a way of defining software to continue functioning under unforeseen circumstances. This means that software should continue working as expected at all times. In this context, working does not only mean that the application is processing information correctly, it also means that only appropriate users have access, data from the server isn't tampered with in transit, and that the application is available to users when it should be. Unforeseen circumstances can include a variety of situations, ranging from malicious actors attempting to hack into a system to an earthquake at the server location. While software developers can't do much about the physical servers that their code resides on, they can try to put up blocks to stop people from purposely or accidentally modifying critical data. These blocks are referred to as controls, and they include things like authentication mechanisms, error handling procedures, and logging. There are several things that need to be considered when trying to perform defensive coding, because while there are lots of benefits, there are lots of drawbacks as well. What level of defensive coding that is implemented will be dependent on the specific project and what the requirements are with regards to the confidentiality, integrity, and availability of the application. The first benefit is that the general quality of the code should be improved. There should be fewer bugs, increased security, and optimized functionality. Additionally, the code should be easier to read and understand, as defensive coding requires software to follow certain standards like naming conventions, comments, and implementation formats. Resulting applications should also be more predictable, as defensive coding will result in data input and output being validated and scrubbed prior to processing. The risks associated with defensive programming are generally more related to the resulting costs, as defensive coding usually requires additional work. For starters, there are costs associated with hiring people to review code, as well as having developers spend time addressing comments from those reviews. On top of that, adding additional code to the application introduces the potential for unused code or code that causes errors in the application. The process for implementing defensive coding is called the Secure System Development Lifecycle, or Secure SDLC. A typical SDLC has the following stages: requirements analysis, design, development, testing, and maintenance. However, this process was updated to incorporate security, as security was being bolted onto projects at the end and was not effective from a functional or cost perspective. The Secure SDLC is designed to make sure that security is baked into the development process, which helps reduce the overall cost of projects while making sure that the final solution is less vulnerable. Secure SDLC has the following stages, which should be concurrent with the standard SDLC: risk assessment, threat modeling and design review, static analysis, security testing and code review, and security assessment and secure configuration. Secure coding is incorporated into each of these areas, as developers will have to consider the security aspect of the application they are writing. For instance, if they determine that an input field could be an attack vector for a SQL injection, then they might create a code requirement to code a field validation and would then have to develop and test that code. The Open Web Application Security Project, otherwise known as OWASP, is an organization that tracks common threats to different types of information systems. In 2017, it released its updated top 10 most critical web application security risks. Injection: passing computer code through input fields to run unintended commands. Broken authentication: any problems related to the identification and authentication of application users, such as passwords being sent in clear text. Sensitive data exposure: allowing attackers to view data stored by applications without proper authorization. XML external entities, or XXE: allowing an untrusted source to upload XML to an application, which is then parsed by the application's XML processor. Broken access control: allowing unauthorized users access to the system in some way. Security misconfiguration: not configuring the application or supporting infrastructure with the most secure settings possible. Cross-site scripting, or XSS, allows an attacker to execute scripts in a client browser in order to hijack sessions or change site data. Insecure deserialization, using an API or application that has been tampered with. Using components with known vulnerabilities. Using modules where researchers have discovered issues that allow for exploits. Insufficient logging and monitoring. Not keeping a history of activity occurring on the system makes it difficult to identify and investigate potential breaches. Fortunately for us, OWASP has also developed a list of their top 10 proactive controls that application developers can implement in order to help prevent attackers from taking advantage of vulnerabilities. Verify for security early and often. Make sure that security is baked into the development process. Parameterize queries. Pre-compile queries and only allow the parameters to be input. Encode data. Translate special characters into different ones so that they are not accidentally interpreted. Validate all inputs. Perform checks to ensure that the expected data is passed through to an application. Implement identity and authentication controls. Make sure that the users who are accessing the application actually are who they say they are. Implement appropriate access controls, making sure that the users accessing application resources, in particular sensitive ones, have the authorization to do so. Protect data, encryption of data in transit as well as data at rest. Implement logging and intrusion detection, tracking activity occurring in the system and reviewing that activity for indicators of malicious behavior. Leverage security frameworks and libraries. Rather than reinventing the wheel every time a new situation comes up, look to what others have created and improved. Error and exception handling. Make sure that data isn't leaked to attackers when errors are thrown and ensure that mechanisms are in place to detect errors. Now, I'll go through the top 5 proactive controls in more detail. Verify for security early and often. Security should be considered at all stages of a system's lifecycle, starting with when the system is initially being planned. This allows developers to bake the security requirements into the system rather than bolting them on at the end and potentially breaking the functionality or not fully covering the system. The graphic describes a possible agile approach for including security during system development, in which security is considered during all tasks. This is critical because it can help address any sort of attack vector, since it requires the developers to constantly consider how a vulnerability may impact a system. Notice how early in the process the team should start thinking of ways that an attacker might try to bypass controls. Test plans are created before coding is started, and during development, code reviews are performed to ensure that standards are being followed. Then, more analysis is performed before code is sent to production, and once it is there, is tested to ensure that new vulnerabilities are identified and remediated. Parameterized queries. Query parameterization is a method of making sure that an attacker can't inject their own code into a system, such as through a SQL injection. Attackers do this by sending valid code into a system, typically through a field, which the system will then execute, as opposed to using it as a parameter or storing it as a value in a database. For instance, they might send the drop tables command through a field they know is going to a SQL database, which may cause the back-end system to delete all of its tables, as it will interpret the field entry as a query instead of as a value. This should be implemented as part of a defense in-depth approach, meaning that the other controls should be in place as well, such as validation on fields to ensure that the correct data type is entered. Pause and think. Which one of the following code snippets parameterizes the query inputs? The first statement checks the parameters, then passes those parameters as arguments to the query. The second query creates the query as a string, then passes that string to the query builder, meaning an attacker could input their own query. Encode data. Encoding data is the process of translating special characters, meaning those that will cause interpreters to treat them differently than strings, into other characters that will not have a special meaning. This ensures that the data sent into the interpreter is not treated specially, meaning that the attackers should not be able to inject code and data should not become corrupted because it is accidentally interpreted as something other than a string. It also helps prevent cross-site scripting attacks by encoding output so that attackers cannot enter their own code into a dynamic web page passed back to a client. Java has an encoder class that developers can take advantage of to encode URLs. It keeps all alphanumeric characters the same, as well as some symbols. It converts spaces into plus signs and then uses an encoding scheme to convert any other characters. This example shows the result of putting the given string through the encoder. Validate all inputs. Input validation is used to check data sent by users to make sure that it matches with what is expected. For instance, if a form is asking for a date, you would not expect that the user would be sending information as an alphabetic character. Additionally, it is important to check whether the information entered is within expected ranges. When an application wants to know the name of a person, it would not want to receive text that is 500 characters long, as that is not normal for a name. Additionally, validation checks might include information that a user does not explicitly enter, but is still sent by them, such as cookies and HTTP headers. This information should be checked so that the application can at least validate that the information is coming from the correct user, that the user is not sending known malicious content, etc. This is another part of the defense in-depth approach that can stop injections and cross-site scripting from occurring. Stop and think. Should input validation occur on the client or the server? Input validation should occur server-side. There may be additional validation for convenience on the client, but the server should ensure all data is correct before processing it. The server should not trust any data that is coming from the client, as an attacker could possibly find a way around the client-side controls since they have access to that computer or could change data in transit. Implement identity and authentication controls. One of the most important aspects of security is requiring that users make an assertion about their identity and then provide some sort of evidence proving that they are who they say they are. If this is not implemented properly, all other controls could fail, since attackers could make false assertions about themselves in order to gain access to resources they should not have access to. OWASP describes several approaches to this. Multi-factor authentication, providing more than one type of proof regarding your identity, either something you are, something you have, or something you know. Tokenization, rather than storing persistent credentials on a client for continued access, provide a token from the server after authentication, minimizing the risk of credential compromise. Secure authenticator recovery. When a user inevitably loses their authenticator, such as forgetting their password, they may need a way to get it back that won't risk the compromise of the account. Session expiration. Systems should create new and unique sessions when users log in for the first time in order to minimize the amount of time that sessions are open, reducing the time that an attacker can hijack a session. If you'd like to check out some more of the source data for this presentation, head over to the OWASP site to read more about these vulnerabilities and controls. Additionally, NIST provides coding standards that help with defensive coding. Thank you.